Now we're going to look at the supremum and infimum. To make life easier, we're going to do this with an example. We're going to use an example to illustrate both the infimum and supremum. Like if you're given something like, let's say, a set of x such that maybe 1 is less or equals to x, let's say less or equals to 10, where x belongs to the set of real number. Now we want to find the supremum and infimum of this particular set. You know that these numbers here talk about number from 1 to 10. As in, 1 is inclusive, 10 is inclusive. Then all the numbers between 1 and 10, they are inside this set. From this set downward here, what are the numbers that are there? We have 10, we have 11, we have 12, and so on, which are not part of the set. Only this 10 is part of the set, others are not part of the set. So all the numbers that are here, we call them the upper bounds. While the numbers that are here, we still have something like 1, we have 0, we have -1, we have -2, and so on. All these numbers are not part of the set, except this one. But from this one downward here, we call them the lower bounds. Lower bounds. While all these ones, we call them upper bounds. The lower bounds and the upper bounds, they are just like wall of a house. As is this, the wall from here to here, the wall from here to here. Then the element from 1 to 10, they are what? They are the elements, they are the member of that particular set. So then the upper bounds, these are the lower bounds. Then among the upper bounds, we have the smallest one among them. And the smallest one here is 10. So that 10 is what we call the least upper bounds. While among the lower bounds, we have the biggest one among them. You know, these are the upper bounds, but this one is the biggest among them. This one is called the greatest lower bounds. This least upper bound is what we call the supremum. While the greatest among the lower bound is what we call the infimum. If this set is A, I can say that inf of A, which means the infimum of A is 1. Then I can say the supremum, the sum of A is equals to 10. But for this particular question, 10 is also the maximum. And the 1 is also the minimum. That is, if the supremum is inside a particular set, I can call it the maximum. And if the infimum is part of the set, I can call it the minimum. Let's look at that. Let me try to explain another example to make it. If a given another set, let's say another set S to be equals to the set of X such that we have, let's say, -2 less than X, maybe less than, maybe, let's say 5. In this case, our supremum, when we have the upper bounds, so the upper bounds are 5, 6, 7, and so on. So the least upper bound is equals to what? 5. Which means our supremum, that is of X, is equal to 5. Then here too we have the lower bounds. The lower bounds are what? -2, -3, -4. So the greatest among them is what? Is -2. So here we can say that the greatest lower bound is what? Is minus 2, which means the infimum of x is equal to minus 2. But in this case, this supremum 5 is not part of the set, so it's not the maximum, which means this one has no maximum. And this minus 2, which is the infimum, is not inside this set, so it means this has no minimum. So we only have minimum and maximum if those supremum and infimum, they are part of the set.